In this last section, we'll look at recursively defined sequences and factorials. So a recursive formula defines the terms of a sequence using the previous term. Or in other words, the term that came before. The format for a recursive definition is always the same. You'll be given a value for a sub 1, and then you'll be given a formula for a sub n that involves the term that came before, in other words, a sub n minus 1. So for example, write the first four terms of this recursively defined sequence. A sub 1 equals 3, a sub 2 equals 2 times a sub 1 plus 1, and in general, a sub n plus 1 equals 2 times a sub n plus 1. All right, so you're always going to be given a number for the first term. So we're told that the first term is 3. To find a sub 2, we were told that we should take twice a sub 1 and add 1. So 2 times 3 is 6, plus 1 is 7. And in general, to get the next term, we should take 2 times the one that came before it. So to get a sub 3, we should take 2 times the one that came before it and add 1. Or in other words, 14 plus 1, 15. And to get the fourth term, we should take 2 times the one that came before it and add 1, or in other words, 31. So that's an example of writing the terms of a recursively defined sequence. One of the most famous recursively defined sequences is called the Fibonacci sequence. And this sequence is really famous because it has so many applications. It has applications in botany, in animal biology, in gambling. I mean, it has a lot of applications, but it's a recursively defined sequence. Write the first 5 terms of the Fibonacci sequence defined by a sub 1 equals 1. A sub 2 is also equal to 1. And a sub n plus 1 is equal to a sub n minus 1 plus a sub n. So let's take a look at this and just really think about what that means. Okay, so what would a sub 3 be equal to? Okay, so a sub 3, in this case n is equal to 2, that's going to be equal to a sub 2 minus 1, 1, plus a sub 2. In other words, to get a sub 3, we should add these two numbers together. Let's take a look at a sub 4. And again, let's focus in on this definition right here. Okay, so for a sub 4, if we're looking for a sub 4, that means n would be equal to 3. So a sub 4 would be equal to a sub 3 minus 1 is 2, plus a sub 3. In other words, to get a sub 4, we should add these two terms together. And that's really the Fibonacci sequence. The Fibonacci sequence simply says, to get the next term, add the two previous terms together. The next one would be adding these two together. So that's an example of a recursively defined sequence. Here's one for you to try. Write the first 4 terms of the sequence defined by a sub 1 equals 3. And to get the next term, take 3 times the previous one and add 2. Give that a try. Okay, let's see how you did. So a sub 2, a sub 3, a sub 4. All right, so what this says is that the next term, a sub 2, you're going to take 3 times the one that came before it and add 2. So 3 times 3 is 9 plus 2 is 11. All right, to get this term, you're going to take 3 times the one that came before it and add 2. That would be 35. And finally, to get this last term, you're going to take 3 times the one that came before it and add 2. So that's going to be 105 plus 2, 107. The last topic is using factorial notation. So some of you may have seen this before, but in case it's new, n And this exclamation mark is called a factorial in mathematics. So it's read n factorial. And what it means is 1 times 2 times 3 times ... times n. So multiplying all the numbers, including n, that comes up to n. For example, 4 factorial would be 1 times 2 times 3 times 4, or in other words, 24. 5 factorial would be 1 times 2 times 3 times 4 times 5, or in other words, 120. Now, the reason we look at factorials is because sometimes they're used in the definition of sequences. All right, so write the first 4 terms of the sequence defined by a sub n is equal to n factorial over n. So we're going to write down a1, a sub 2, a sub 3, and a sub 4. So a sub 1 would be 1 factorial over 1. That would be 1 over 1, or in other words, 1. A sub 2 would be 2 factorial over 2, and 2 factorial is 2 times 1, or in other words, 2. So 2 over 2 is also 1. A sub 3 would be 3 factorial over 3. Now 3 factorial would be 3 times 2 times 1, or in other words, 6. So we have 6 over 3, in other words, 2. Why don't you see if you can fill in this last number yourself? Okay, let's check your work. So that would be 4 factorial over 4. And remember, what's 4 factorial equal to? That's 4 times 3 times 2 times 1 over 4, or in other words, 6.